Hello everybody, this is Darmus. It has been a long time since we did our last freefall experiment. Today we're going to do lead versus steel, and we already did 4 trials here. We're not recorded, but I guess that's fine. So the last value was 5994. We press this button here, 5992, 5992, and as usual we expect that to be a 0.3 milliseconds difference, because this is the height of 2 meters, and like yeah, 5997. Well, the differences are, the standard deviations are a bit big. I think it's because I'm not centering it well. I think it's easier to do this when I hold the camera horizontally. I mean vertically. Let's see, 5988. And I'm actually left-handed, so it's a bit inconvenient to do this with the right hand. Oh, come on. Okay. That's a bit close there. Hope it won't touch it. 5988. Okay, 2 more trials, and then we have to switch the content, swap the content. Let me switch hands. Yeah, it will be better because I'm left-handed. Okay. 595. Okay, one last time. Five, 996. Okay, so we got our average here. Now we have to swap the content. But first I should show you the weight. $72.4 2496. Well, what I wrote down here is 72.5, almost the same. But let's also add 2496. 2496. Well, so the lead mass has to be slightly heavier than the steel mass, so that because it's predicted to fall slower, and so then nobody can blame an excess weight for that. So now let's put all of this here. Okay, and this is the steel ball we're going to replace it with. And let's weigh this real quick. Okay, 72.466. 72.466, and as you see, it is lighter and predicted to fall faster. 0.3 milliseconds faster. Yep. Okay. 25992. Yeah, wait a moment, what was this? 5992. Yep. Five nine nine five. It's hitting 5995. Shouldn't be hitting it. Five nine eight eight. Five nine nine one. 5991. Five nine eight four. 5982. 5982. Okay, so now we actually have kind of a 0.3 milliseconds difference. But of course, this time the standard deviations are terrible. Five nine eight seven. Okay. Five nine nine three. We hit again. Maybe let's do it one more time. Shouldn't hit. Well, it hit from below. 5986. Okay. I think 2 last times. Okay. Oh, 5997. That made the gap smaller, but again. Okay. 5986. 5986. So we see roughly a difference of 0.3 milliseconds. Let's just calculate it real quick. Okay, 2.4. Yeah, it should be 3, but well, there are some outliers. Yeah. So that's the experiment. It's pretty accurate. Of course, if somebody else was filming me, then I could get smaller standard deviations, because then I could focus more on putting it right in the middle. And yeah, should be the photo gauge should be placed in a way that they don't get hit. I guess I should use more cushioning so that it doesn't jump back up after dropping. Yeah. Okay, that's all for now. See you.